And just a reminder, today's Wednesday webinar is Computer Science in Elementary School with the CS4 Success team. So we have Julia and Troy here, which are both co-founders that are joining us. Hopefully Julia will be back, and if not, Troy will take the wheel.
Back to Ireland. They found me a job in Kildare at a teaching hospital.
Hello, everybody. This is Lindsay. I'm the Director of Professional Learning. I just wanted to let everybody know your PDH link will be dropped in the chat at the end of today's session. You can utilize that chat at any point today, and we will make sure we get your answers to any questions you may have. And this recording will be provided for you tomorrow in an email recap, along with any other resources that are shared today. So we're excited to have you really be invested in today. You don't have to worry about taking notes. We'll do that work for you on this side of things. But Troy, would you mind introducing yourself while we wait for Julia to join?
Sure. Hello, everyone. My name is Troy Williams. As Ashley said, I am one of the co-founders and principal consultants here at CS4 Success. So CS4 Success, we're a consulting company that focuses on computer science education, trying to work with school districts and organizations to provide equitable access to quality computer science education, programming, and potentially events, out of school projects, out of school programs for high school students, for middle school students, just that entire pipeline that leads to the opportunities in post-secondary or in career. And we are very happy to be here. Apologies for the technical difficulties. So Julia, I'm gonna try to give her another second or two to get back with us, or else you will endure my presentation skills. So give me 1 second. I'm just gonna reach out to her real quick. 1 sec.
That's all right. I think this group is all too familiar with tech happening. It just is the way of the world right now. So you should have received the slide deck from the email yesterday that all of you got, articulating all the details to join. If not, we'll make sure we drop that in the chat as well. But so far, we are really enjoying Kino as a new platform as an alternative to Zoom. So Kino itself allows you to have this share space where you can talk similar like Zoom, Google Meet, but the really cool thing about it is has the opportunity for that ambient noise to occur. So I can go into smaller settings with people and still have that background noise that everybody enjoys. So we're loving it so far and using it for everything that we've been doing, and we'll continue to be using it.
Thank you. So I guess I don't want to keep you all waiting too long. So I'm going to give this a shot. So bear with me. I appreciate you all. I think, are you all able to see my screen?
Yes, we are.
Okay. So we're going to talk about computer science implementation. Give me 1 second. I'm just going to let her know that I'm starting. All right. So again, I'm Troy Williams, one of the co-founders here, along with my colleagues. We have Julia Flores, who will hopefully be joining us again in a couple of minutes. And today, also Abril Vela, who could not be here today, but the three of us are the co-founders for CS4 Success. And what we're going to be talking to you all about today is computer science, computer literacy, implementation, so what are the requirements in the state of Illinois? And what's the difference between computer literacy and computer science? And then also, how do we implement? So let's jump into requirements. All right, so specifically for elementary schools, there was a House Bill 2170 that passed with specific requirements for computer literacy, and for high school, there were requirements for computer science. So the goal is to ensure that all the districts are providing opportunities for students to receive developmentally appropriate opportunities to gain computer literacy skills beginning in elementary school. And so school districts will have to submit to the State Board of Education an annual report that includes, at the very minimum, information regarding educational technology capacity and policies, device availability for students, school-based access, and infrastructure, professional learning, and training opportunities, and documentation of developmentally appropriate computer literacy instruction embedded in your district's curriculum at each grade level. So at the high school level, beginning in school year 23-24, so the computer literacy requirements that I just spoke of, that starts this coming school year. 23-24, next school year. So each school district is to maintain, basically offer a computer science course based on the standards that the Illinois State Board of Education are putting forth. So that means at least one computer science course aligned with the rigorous learning standards, which again are provided by the State Board of Education. And if you have a copy of the deck, there are links that are provided that can take you to what those standards are, what those courses are, and you can go through that and see what you may need to work on, what you may need to think through, what may work best for your school and for your school district. Okay. So what are we proposing? So every school district should integrate computer literacy at every grade level. Just as far as defining computer literacy is not computer science, but computer science teaches computer literacy. So computer literacy is, look at computer science as the larger umbrella, and computer literacy is a component of computer science, but not vice versa necessarily.
Excuse me, Troy, forgive me for interrupting. Julia is back with us, so she joined from her phone, so you can just stay on stage and present the screen, and she can take it away. Julia? We can't hear you.
How about now?
Yes.
Wonderful.
So
I was trying to get your attention earlier too.
Oh, okay. Hopefully I didn't miss anything. But where I was at, Julia, I just talked about what the requirements were, what the requirements are, and I'm at the stage of what are we proposing right now.
I see. Okay, so one of the things that I wanted to make sure that we emphasized when we were talking about the requirements in particular is that second section that outlines what the expectations are for you to report. It mentions that you have to report the type of educational technology that you have, your capacity, the availability, and also document what you're doing to bring computer literacy to your students at every single grade level. And to us, that means that you're going to have to conduct some sort of a needs assessment in your buildings to make sure that you're identifying what type of computers you have or other tech like iPads. And that'll be important because when you actually get to the part of selecting the curriculum that you're going to use, some of these curricula only operate with certain types of computers or certain, the age of the operating systems, and that's really important. So in the elementary school level, it's important to know that there will be some sort of a needs assessment that you're going to have to conduct. And the reason why we mention the high school level is that in the high school, we're always preparing students for the next step, right? And at the high school level, there's also a computer literacy expectation. They do have to incorporate or infuse computer literacy into the courses at the high school level, but they also have that additional requirement, which is to offer. Now, notice it does not say that the students have to take a computer science course, but it does say that the schools have to be ready and prepared to offer a computer science course. So I think that's an important distinction to make. So if you could go to the next slide. So yes, the proposal. Computer literacy and computer science are not the same thing. If you're teaching computer literacy, that is not computer science, and we're going to go over why that's true. However, if you teach computer science, you will teach computer literacy because you're going to need the computer, the students to understand the computer in order to get through that CS education. Next slide.
Okay.
Here we are.
There we go.
Now that we know what the state requires of us, we have to figure out what the differences are between the two, between computer literacy and computer science. And before we get into that, let's talk about the commonality, which is the computer, because we need to be clear on what that is before we jump into defining those other two subjects. Although computers weren't new when I started teaching computer science, and I didn't get a chance to tell you my background, but I was actually certified to teach accounting, entrepreneurship, and finance. And when I came to the building for the first time to get my schedule to teach, there were nothing but IT classes on there. And I didn't have an IT background. So I was terrified. I had like 5 days, I think, to get ready to teach 4 different IT classes. And although computers weren't new at that time, like close to 20 years ago, they weren't as prolific as they are now. There weren't that many different types. So my understanding of computer is exactly what you see on the screen. And even that, you didn't see very many laptops. At least I didn't back then. It was just the desktop. That was my idea of what a computer was. But these other 2 things on the screen are also computers. And back then, I couldn't tell you why the 3 of these were computers, or even what the similarities were. So let's go to the next slide. So let's try to think about that. What do those 3 computers have in common? Well, all 3 have a way to capture or for you to input some sort of data, whether that's the keyboard, whether that's the remote control for the computer, the keys on the calculator. And then the unit has to be able to do something with that data, right? We build computers to do things for us, to make life easier. So these store, they process, they do something, whatever it is that we tell it to do, and then it retrieves the data. Let's say you save something, you can call it back on all 3 of those units. And then lastly, it displays it, or it creates an output of some sort, right? It doesn't necessarily always have to be what you see on the screen. It's just a matter of being able to give something back to you. Next slide. So then, knowing that these 3 things have to happen, what makes the system, what makes a computer. So first, you're going to need individual pieces, like the actual things that are going to do something. So we're talking about hardware, and that's things like the keyboard, the microphone, the mouse, the camera. All of those pieces, these tangible pieces, they capture and input or allow you to input data, right? But you also have things like the hard drive, the motherboard, the fan, that are also carrying out other types of functions, like operating functions in the background that you don't necessarily see. But those things are just fancy paperweights if they're not connected, if something isn't telling them what to do, if there isn't the orchestra director that's telling it, you turn on now, you send these things that way. It needs that program. It needs software that makes the whole thing come to life. So software is just a set of instructions designed to carry out a specific function. Now, there are all types of software on computers. There's the operating software that does just that, tells it when to turn on, what goes first, what goes next. But we also have software like the apps that you have on your computer. So the software for Microsoft Word, right? That carries out a different function. So there's all kinds of different things. It's important to note also that if we liken programming, a programmer, to somebody writing a paper, when you're going to write a paper, the first thing you do, you don't typically just jump into the paper, especially if it's going to be very long and complex. You create an outline first. The same thing is true of a programmer, only that instead of calling it an outline, they call it an algorithm. So they're doing a brain dump. Like the first step that this needs to do when I click start, or when I left click the mouse, is this. Then it's going to do this. Then it's going to do this. That's called an algorithm, and it's very similar to the writing of the paper, right? Next slide. So now, if that's what the computer is, if it's just a combination of hardware, software working together to create this system to do things, whatever those things are, then what is the science of computer? What is computer science, right? So if we go back, these devices were created to do something for us, right? The calculator was designed not because we didn't know how to add or subtract, but because we needed something to do it at a higher volume, to do it faster than us, right? So we needed to be able to input some sort of data. So in computer science, the very first thing that I usually think of is data. We need to think about, how do we represent data? How do we create databases? How do we display it? That's one part. The other parts, like we just talked about, are the hardware. So you will study hardware, what needs to be where in order to make this thing work. You will also obviously talk about software programming algorithms, because that's also needed. And internet and network. If you think of internet, the internet and network, it's just a way for the computer to get more data. It's a way for it to connect to other locations where there are more data. So that's absolutely necessary in the study of computer science. And like anything, these days we want to really make sure that we're teaching students and that we as programmers know what the impacts are of the things that we're creating. So you will absolutely study the impacts of computing, ethics, things of that nature. You'll talk about, like, if I create this design, is there anybody I'm excluding? Is there anybody that's benefiting over somebody else if I create this thing? And really start to use that frame of mind to refine and improve the things that you create. Next, there we go. So then, what is the definition of computer science? This is the exact definition that we pulled from ISB. So computer science is the study of computers and algorithmic processes, which means the beginning stages of the programming. It includes their principles, which the principles is data, their hardware and software designs, the application, and impact on society. However, the really telling part here is this last part. Computer science does not include the study of everyday uses of computers, computer applications such as keyboarding and accessing of the internet. When this first came out, That was because there were so many people that felt that if they just covered computer literacy components, that they were teaching computer science. So it was really important for ISB to say, hold on, there are two very different things going on in there. When they created the computer literacy requirement, they didn't put out a computer literacy definition, though. I think the understanding was that it was implied. It was buried in this computer science definition. Move to the next slide. It's that last part. Computer science does not include X, Y, and Z. So computer literacy is the study of everyday uses of computers. Computer applications such as Google Docs, Sheets, Slides, and could include keyboarding and accessing the internet. And accessing the internet safely is probably the part that was missing there. So it's broadly defined as someone's ability or knowledge of and ability to use computers and the related technologies efficiently and effectively. Next slide. So then, what are the differences? So computer literacy teaches a student or a person how to use the computer and whatever's already there. Computer science, however, helps a person understand the computer so well that they could create those things. They could create the computer. They could create software. They could improve technology that already exists to solve a problem, right? Which is why we're saying you could teach students computer science and they would learn computer literacy, because it's absolutely foundational to the process of problem solving using the technology. Next slide. So what are we saying should happen, right? We're saying that you could use computer science education to, one, fulfill your computer literacy requirement, which is most prominent. That is expected this coming school year, whereas the computer science requirement is the following school year, but that's for high school. It'll also prepare your students for the computer science high school requirement. So it's very important to make sure that those students can address whatever they get thrown at them in the high school space. But it also allows students to be exposed. It provides that career exploration to an industry that is in unbelievably high demand. There are many majors right now that are in colleges that are called CS and X, and that is computer science and another subject. So you'll see fusions of courses like computer science and music, computer science and art, computer science and anthropology. Like because computer science is making its way into all of these different subjects, making our life easier, which is exactly what the intention of building these things was for, is to make life easier. So even if some students may be like, I don't want to do that, it's okay. You're probably going to see computer science in your field in some way, right? So how do we do this? Troy, next slide. Okay. Are we okay? Okay. So how do we onboard it, right? This is the last stage. How do we get CS to work for you and work for your students? Well, there isn't a shortage of CS content or CS curriculum out there that'll fit your school day. However, you have to really sift through to find the best fit for you. And in order to do that, you have to ask yourself these 3 questions. When it comes to providing students with access to CS, what is the overall goal within the classroom and within the school community? If you're putting together a computer science program to span from one grade to the next, or maybe pre-K through 8, right? It's important to understand what is it you're trying to accomplish. What should the students know and be able to do by the end of this experience and by the end of the entire program, if you're sequencing courses together, right? What are the students required to complete or know or be able to do by the end? And in order to do this, I really recommend you go to ISBE's website and find those standards. The ISBE approved computer science standards are sequenced by grade band, so you should be able to see what is expected at every grade band, and they were banded like that so that you have flexibility to be able to offer it, whether it's one class once a week or it's integrated into another subject. So there's a lot of flexibility there. Another point to also make, those ISBE CSTA standards, their ISBE computer science standards, you will also see a lot of introductory high school courses address only the first and second grade band. And that's done because those computer science standards are progressive. So you wouldn't be able to just necessarily jump in to the third, fourth, fifth grade band if you haven't addressed or taught the students the K1 and 2 standards. So you should really be clear, how do I want to lay all of these out? Do I just want to dive into one of these subjects or within those standards? So that's definitely important. And 3, how are we going to make these experiences accessible to students? And I think it's important to say to all students. In working in Chicago Public Schools, one of the things that we noticed was that when computer science was available in a building or even at the high school level, there were certain populations that were excluded, and some had absolutely valid reasons. If an IEP says this can't fit, then it doesn't fit, right? However, we also saw that a lot of students that were English language learners were excluded. And it wasn't until we came to the table with those English language learner teachers that we could figure out how to make it work for those students. So that's another thing that you're really going to have to think about, is how do we make sure that everyone is getting access if that's what your vision is for your school. Troy? So now, developing an implementation plan. The implementation plans are probably one of the most critical things for the success of a program, for more than one experience for the students. So we really want to make sure that you all have a set of guidelines or create a set of guidelines for onboarding your CS coursework and other experiences. And we say other experiences because it's not limited to just the classroom. You could also make sure that you have after-school programs, before-school programs, or that you just give parents a list of programs that the students can also go to outside of the school day. So it's really flexible for you to figure out, like, how do I get the students who are more interested in this more opportunities? It doesn't always have to happen inside of the school building. But for right now, we're thinking school building, right? These plans outline all of the requirements you need to achieve a successful offering. And although these are listed in this order, you will find that one of these may be more important than the other, just depending on what you have available in your building. So the expected student outcomes, I'm a curriculum person, so of course I'm always going to say that that's the most important one, but you really have to be clear, like, what is it we want our students to do, know, display, showcase, and then you look for your desired curriculum and content, also based on what your vision is. So if you want to make sure that the students have it available in their tech special, or if you want to make sure that it's integrated into math, you can do that. There's a curriculum out there for you. But you also have to be really careful about the prerequisites when you start to sequence courses, especially if you're sequencing courses that weren't designed together. So if you have a CS Discoveries and then you wanted to sequence Scratch afterwards, there may be some issues there. So really make sure that everything speaks to itself. Teacher training is probably the most critical component of success for this. Like, I say that for almost all of these pieces, but it really is. Whenever you do identify your curriculum, make sure that they're offering some sort of training for your teachers, and also try to see if there is some sort of a learning community. From my experience in working as a director of curriculum, almost all have something like that. It's just a matter of you asking. So ask if there's a professional learning community. Ask if there's even a Facebook group. There are a lot of those out there where your teachers can jump in and ask those questions that they need answered to move forward. But equipment and technology might be another thing that really limits what you can or can't do. One time we had a principal say, hey, we want to offer all of the Apple classes, but they didn't have any Macs. So we were like, we're not sure what you expect us to do here. You really need to have a Mac in order for this to work. So that's also something that's very critical to making sure that you find success. So now, what's the next step? Troy? So there are two ways to go about it. You have a standalone course, and by a standalone course, I don't necessarily mean that you have another subject that you're running Monday, Tuesday, Wednesday, Thursday, Friday. What we mean is you find a special that already exists, perhaps, and you take over that special. So we used to see this a lot in Chicago Public Schools, where the technology teacher, that technology special, became the computer science course. Again, you would have to have a fair amount of training, but it provides consistency. So at the very least, you know that you have carved out 40 minutes, 45 minutes, 20 minutes, depending on how you structure it, a week, and students could really build skills that way. It provides the maximum access and exposure to CS topics. But we've also seen incredibly successful integration. So if you don't have the capacity to infuse that standalone, or maybe because only 3rd, 4th, and 5th graders get the tech special, really looking at other subjects might be the way to go. So in order to do this, we would say to really sit down and look at the computer science standards and see where there are overlap. There are many standards that you'll find that overlap with math, with science, and you'd be surprised there are even some literacy standards that overlap. So it allows them to learn those CS topics, continue to learn whatever subject, so whether it's math or science, and practice computer science skill development. So here we have an example. So if you have a library or media period, and we say this, we had one of our most successful implementations was a library media period at Tanti Elementary School, where all the students participated once a week. The teacher of this course decides what they will select. So you could use, there are many curricula out there. So you could use code.org, you could use Scratch. There's Take in Charge. There's so many really cool ones out there throughout the year, and they use that to learn more about creating digital media using coding. We've also seen this in music because there's a program called EarSketch that will allow students to learn about programming and create music. It's really phenomenal. And in the integration side, so students don't have to have access to a dedicated tech class. However, if your 8th grade math teacher is very excited about using computer science to help the students understand algebra problems, they can decide to integrate CS content into some of their classroom activities so that students can deconstruct some of their daily activities using graphing practices. And the curriculum that comes to mind is Bootstrap. Bootstrap is an algebra class that has, there's a strong background in computer science. But there's also, for science classes, there's also something called Project Guts, which lets the students model infectious spread using the software. It is unbelievably hands-on. It brings everything really to life for students to be able to see how these things that we're talking about in the class actually apply to real world. So it's really phenomenal. So now, what is next? So now we recommend that you start drafting your implementation plan. And you could use our implementation plan for elementary schools to get started with your school or your district team. And we do recommend that a team work on this. And you identify your content and your curriculum to really put together this plan. However, we already know that you're going to have to create that needs assessment for all the tech. So maybe you start there because that's what's being expected of you immediately. However, if you want help, you could book an integration consultation with our team, or you can schedule a complete implementation package where we come to your building to help your team launch your CS program. And just for you, we have a coupon code that gets you a 20% discount. You have to use the coupon code IDEA, all caps, and we make that available just for you all.
So yeah, I know there were some questions. I'm sorry. I'm going to go into the chat here to try to get to some of you all's questions. And so I'll kind of read them off, Julia, and we could take a stab at trying to get some of these questions answered. So someone wasn't able to, okay.
Is there a way to allow people to raise their hands? And then
yeah, maybe. Yeah, I think they were trying to sort out getting access to the slide deck for the most part.
I see.
And then just some comments. Thank you, Lindsay, for jumping in there. Are there any questions that people want to get addressed? Are people able to come off mute if they have a question? Ashley?
Yes, they can. They can just unmute at the bottom of their screen. If they're on a mobile device, tap the screen. The control bar is going to come up, and you can unmute your microphone, ask your question.
Wow.
We have pings.
Oh, so Jen asked, where's the plan that you noted that we could use? It didn't appear linked in the slides. Let's see. I believe it was
on slide 23. No, that's not where it is.
Yeah, there should be a link in the slide.
Let me see.
Oh, it was under.
Oh my goodness, I just saw it yesterday. Where'd it go? We might have to all view that one and send it to everybody out there.
Yeah.
We will
Sorry
send
about that.
Follow-up email to all the attendees most likely tomorrow, and we'll make sure to send that link to everybody in that.
Yeah. Okay, so so Judy asked, will the annual report be due at the end or the beginning of the academic year? Do we know?
So the House bill doesn't specifically say when. However, when I asked before, apparently there's a report that goes out to the regional offices of education that has a whole bunch of other things that you have to report about things that are available in your building. And I think it goes out with that. And the things included are the device availability for the students, school-based access and infrastructure, professional learning and training opportunities that you had available to staff, and documentation of developmentally appropriate computer literacy instruction that was embedded in the district's curriculum at every single grade level. So all of those things are due to, I want to say it's the ROE, and they eventually, or maybe even just, maybe it's the State Board of Education and the ROE are the enforcers, if I recall right. But yeah.
Yeah. So Eric Santos asked, like, what are those requirements? What are they supposed to submit? So that's on the slide that says what's required of elementary schools.
Mm-hmm.
you can find that information there, Eric, once you get a copy of the presentation that you can access. We'll make sure that happens for you.
Absolutely.
Sweet.
I also know that although right now they don't have, they being ISB hasn't rolled out much more on computer literacy. I do believe there is more information coming. It's not just what you see in the House bill. So there will be more support and more clarification about exactly what is expected, exactly what competencies are considered computer literacy. So stay tuned for that.
Yeah, and also, Jesse, you can feel free to come off mute. Jesse Irvin from ISB.
Oh, hey.
Yeah, Jesse, if you want to, you feel free to jump in. But Jesse says the technology your district would be documented on the district technology survey. And then Jesse provided a couple of links. If you access the chat, you'll be able to see the links that Jesse provided.
Yeah. So, oh, sorry. Can you hear me?
Yeah.
Okay.
Yeah,
The technology report is with the LTC report, the District Technology Survey, and I just asked my colleague who's in charge of gathering that data. For this academic year, the deadline was November 15th. So it's usually released at the start of the school year and asked to be completed by the fall. With other guidance that's coming out, we're working on a computer literacy knowledge and skills continuum that should be out very soon, and it will document what skills should be introduced at what grade level, K-12, when students should be beginning those skills, when they should be working on developing those skills, and when they should be secured by. And then we also have other groups working on supplemental resources for computer science that we hope to get a flyer put on the website once their work is complete. That's similar to the Teach Act resources, if you've seen those on our website. And then we also are in the process of having our emerging technology group create some, we have, I believe there's 9 different categories of emerging tech. So they are working on gathering resources to put on that document for us to share out. We have a pre-K group that is doing some great work on crosswalking the early learning standards with computer science standards to show how teachers may already be incorporating computer science into their lessons and they don't really realize it. And that's the hope eventually, maybe to get that done for each grade level throughout K-12. Yep, those are our, sorry, I was just trying to think if we had any other work groups. There is a spot on ISB's website. On our instruction page, there's a calendar you could search for resources right now. You can check computer literacy or computer science as a filter, and you could have resources pop up, but we're working on getting some documents together where you just can go to one spot to find computer literacy guidance and computer science resources.
Thank you so much, Jesse, for
You're welcome.
Yeah. Are there any other questions? Well, we really appreciate your time and your attention. Apologies again for our technical difficulties. Thankfully, Julia was able to come back and save the day. I don't know, so Ashley or Amber or Lindsay, do you all have any parting words?
Yes, so I believe Amber is going to put the PDH link in the chat if she has not already. So if you don't see that, let us know. And then we also have a follow-up Q&A scheduled to talk more about this on Tuesday, April 26th. So that's next Tuesday. So I think Amber's also going to share the link to register for that. So if you leave this and you're like, wait a minute, I have a ton of questions I didn't think about, definitely join us next Tuesday for that follow-up Q&A. And then, like I said before, we will send out an email probably tomorrow with those links and the slides and all that and a recording of this so you can have it to keep. But other than that, thank you so much to the CS4 Success team for presenting today. It was wonderful. And thank you to Raviv from Kino for hanging with us and getting us used to this new platform. And thank you all for joining. So with that, if there's no other questions, we'll see you all later. Thank you so much.
Thank you, everyone.
Thank you.